All right, we are starting where we left off. We just finished m's. We're going to move on to letter n. And in n, we're doing a problem that's very similar to m, but in this case, the -2 is directly beside a set of parentheses. So the -2 goes to the entire set of parentheses. So the -2 goes to the 4, and the -2 goes to a. Both of these have a negative exponent, so they need to be flipped over the fraction bar. So I'm going to write a 1 in the numerator. Then I'm going to take the 4 to the -2. The entire base and the exponent combined need to flip over that fraction bar. So in the numerator, I'm left with a to the -2. In the denominator, I have 1 times 4 to the 2nd power, because the -2 becomes a +2 when it flips over the fraction bar. Next, I'm going to take the a to the -2, and I'm going to flip it over the fraction bar. In the numerator, I'm left with a hidden 1. In the denominator, I get 1 times 4 squared times a squared. The -2 becomes a +2 when it flips over the fraction bar. 1 times 4 squared times a squared is the same as 4 squared times a squared. 4 times 4 is 16, so our final answer is 1 over 16a squared. Now we're going to summarize what we've done in the past few videos. So let's start with this problem. A over b, both variables, and m, a variable. We'll always use variables to summarize. This is the example in which we take the power and we give it to each piece. So power to a group you distribute to both the numerator and the denominator. So we have a to the power of m over b to the power of m. In this case, the bases are the same. So when the bases are the same and you have a fraction, subtraction better be your action. So we have b to the power of m, the numerator's exponent, minus n, which is the denominator's exponent. So it's b to the power of m minus n. The next rule that we're going to summarize is the negative exponents rule. Negative exponents leave a scar, so you knock them over that fraction bar. The whole thing, the base and the exponent, flips over the fraction bar. And in the numerator, we're left with a hidden 1. So 1 over b to the power of n is equal to b to the power of -n. All right, next example is b to the 0th. And b to the 0th is equivalent to 1. Power of none, you get a 1. Now we're going to work on some examples, page 343 to 344, numbers 12 through 16. Number 12a, power to a group you distribute to both the numerator and the denominator. So we get 5 to the 3rd over 4 to the 3rd. 5 to the 3rd is equal to 5 times 5 times 5. 4 to the 3rd is 4 times 4 times 4. 5 cubed is 125. 4 cubed is 64. 12b, power to a group you distribute to both the numerator and the denominator. So we get 5 squared over d squared, which is 25 over d squared. Now, since the problem is set up like this, we need it written in this form so that we know that x is equal to 2. All right, power to a group you distribute to both the numerator and the denominator. N to the 3rd, we leave as is. 4 to the 3rd is equivalent to 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So y equals 64. And x equals 3. Number 12d. Power to a group you distribute to both the numerator and the denominator. Oops. So the 4 goes to the t to the 3rd and to the s. Next step, we have to use a different rule. Power to a power you multiply. So that means that x is equal to 12 and y is equal to 4. 13a gets a little bit more complicated here. It's still power to a group you distribute to both the numerator and the denominator. However, in this case, the numerator is made up of two factors. So you need to be careful to give the 2 to each piece, because it really looks like this. It's like 4x over n, and they each get that power of 2. So you got to then do a final step and take the 2 to the 4 and to the x. So in the denominator, we have n squared. 4 squared equals 16. And we get 16x squared over n squared. Okay, the next problem. There are two ways to do this problem. The first way, I'm going to do it a little bit slower, and I'm going to show you every step. And then the second way, I'm going to do it faster. So here's one option. You can go ahead and right away take the 2 to the whole numerator, and then you can take the 2 to everything in the denominator. And that was power to a group you distribute to the entire numerator and the entire denominator. In the denominator, I have 8 squared, x to the third squared, and y squared. And that's really y to the first. And then we need to simplify. So we take 32 and we square it, and we get 1024. 1024. And then I take x squared and I square it. Power to a power you multiply, and you get x to the fourth. Again, we use the rule, power to a power you multiply, and we get y to the 10th. In the denominator, we take 8 and we square it, and we get 64. And then we take x to the third to the power of 2, power to a power you multiply. Power to a power you multiply. We do it again, and we get y to the second. The next step we need to take is simplification. So 1024 divided by 64, we get 16, and that goes in the numerator, and I want to show you the reason why it goes in the numerator. If you take 1024 and you divide it by 64, let me give a little bit more room so it doesn't look messy. And you divide this by 64, you're going to get 16. If you take the 64 and you divide it by 64, you're going to get 1. So 16 over 1 is 1024 over 64 reduced. So that's why the 16 is going to go in the numerator. Of course, if you didn't know right away that 64 went into both, you could start with 8. 1024 divided by 8, you'd get 128. 64 divided by 8, you get 8. And then you could try again. Maybe it's divisible by 8, maybe it's divisible by 4. Let's try 8. 128 divided by 8 is 16. 8 divided by 8 is 1, and we get 16 over 1. So 16 is in the numerator. Now we'll take this next part, and the results of the subtraction problem is always going to go in the numerator. So when the bases are the same and you have a fraction, subtraction better be your action. So you take the numerator's exponent and subtract the denominator's exponent. And I'm just going to copy down the y's and do that, complete that simplification the next step. So I have 16x to the negative second, y to the 10th over y to the second, because 1 times y to the second is just y to the second. Once again, I can use the rule. When the bases are the same and you have a fraction, subtraction better be your action. So I'm going to start down here, 16x to the negative second, y to the 10th minus 2. Once again, the results of the subtraction problem goes in the numerator. So we're left with 16x to the negative second, y to the 8th. And then what I'm going to do is I'm going to knock this over the fraction bar. Negative exponents leave a scar, so you knock them over that fraction bar. When you flip the base and the exponent together over the fraction bar, the sign of the exponent changes. So in this case, it went from a negative to a positive 2. And our final result is 16y to the 8th over x squared. Now I'm going to complete this problem one more time, but I'm going to do it in a different order. It doesn't matter what order you do it in as long as you follow your exponent rules. So let me copy down 13b once more. So it was 32 x to the second, y to the fifth, over 8x to the third, y, and then that whole quantity to the second power. So in this case, instead of taking the 2 and giving it to everything, I'm going to simplify before I deal with that power on the outside of the parentheses. So 32 divided by 8, we're going to get 4. X to the second divided by x to the third is x to the negative first. And remember, when the bases are the same and you have a fraction, subtraction better be your action. So I took 2 and I subtracted 3 and I got a negative 1. The result goes in the numerator. If you want to show that it's in the numerator, you can put a 1 underneath the numerator. And then 5 minus 1, we get 4. And this is all to the power of 2. Okay. 4x to the negative first y to the fourth over 1 is the same as 4x to the negative first y to the fourth. And then we're going to distribute the 2 to each piece. So power to a group, you distribute. So I take 4 to the second, x to the negative first to the second, y to the fourth to the second power. 4 times 4 is 16. Power to a power you multiply. Power to a power you multiply. And then finally, negative exponents leave a scar, so you knock them over that fraction bar. So it's 16y to the 8th over x squared. 16y to the 8th over x squared, and you'll notice that it's exactly what we got the first time. So either way, it doesn't matter. You're going to get the same result as long as you follow your exponent rules. Now you should already know anything to the 0th power is equal to 1. Power of none, you get a 1. Some people, they do all of the work. Power to a group, you distribute to everything in the numerator and everything to the denominator, and everything in the denominator. And they do 4 to the 0th, y to the third to the 0th. They do all of this work. And they find that 5 to the 0th is 1, x to the 0th is 1, 4 to the 0th is 1. Power to a power you multiply. You get y to the 0th. And then, oh my gosh, 1 times 1 equals 1. Y to the 0th equals 1, and 1 times 1 in the denominator is 1, and 1 divided by 1 is 1. So hopefully you don't have to do all of that work. You can just see that immediately. Power of none, anything that has a power of 0 is going to give you 1. So you don't have to do all of this work. All right, 14. 14a is 5 to the 7th over 5 to the 5th. Bases are the same and you have a fraction. Subtraction better be your action. So you take the numerator's exponent and you subtract the denominator's exponent and we get 5 to the second power. So y equals 2. 14b, once again, we write in our parentheses, we put in our subtraction sign, and then we put in the numerator's exponent here, the denominator's exponent here, and that should equal 3 to the 6th. So that means that x minus 5 needs to equal 6. To get x alone, we use the inverse operation, and we get x equals 11. And just picture, 11 minus 5 would give you 6, so it works. 14c, bases are the same and you have a fraction. Subtraction better be your action. I want you to write your parentheses, fill them in second, and we get t to the third power, so y equals 3. 14d, when the bases are the same and you have a fraction, subtraction better be your action. So we get 6.4 to the 0th power, so y equals 0, and this whole thing equals 1. 15a, when the bases are the same and you have a fraction, subtraction better be your action. So we get 7 to the 7th power. If you want to write it out, you would write 7 times 7 times 7 times 7 times 7 times 7 times one more 7, I think. 1, 2, 3, 4, 5, 6, 7. And then you multiply. So this can be a very large number. All right, number 15. You know what? Looking at the time, we're almost at 15 minutes, so we're going to have to end this video.